Today's topic would be generative AI for 2026. So generative AI was been here for a very long time. Today, Harish is going to talk about how and when it started, what it is not, and we're going to talk about how we're going to use some use cases, and then he's going to walk us through use cases, and also we're going to share you a lot of use cases that are being currently worked on in the industry. But Harish is going to choose one use case and then walk you through what exactly generative AI does and what it's capable of, what it is and what it is not. Thank you so much, Harish, for being with us today and helping us with this webinar. Over to you, and let's get started.
Yeah, thanks, Sharat. So first of all, very good morning to everyone. And as Sharat mentioned, so we are going to see that what are the new changes or what are the latest update that we have in the Gen AI in 2026. And also our main focus is also some kind of a hands-on. So in terms of the fine-tuning, I will take a one quick use case that in the Gen AI we have multiple components, and in this multiple components, I will pick one of the components and discuss this component in little bit more details. So that is our main agenda. So if you talk about this generative AI, like almost everyone is aware that from the last 5 to 6 years, when OpenAI came in the market and they introduced the ChatGPT, so we were surprised that how a LLM or how a model knows the answer of everything. And this is where the first time the generative AI comes. Generative AI is also a type of AI, guys. Okay, so AI has a different branches like machine learning, natural language processing, deep learning. Then we have the Gen AI, or nowadays we have the concept of Agentic AI. So AI things we already know that we have the artificial intelligence where we try to mimic the human intelligence. In this AI, we are developing the models which mimic the human intelligence system. Means that these AI models will also have the problem solving ability, logical ability, also learn from the past experience and improve itself. If we talk about that what we have now, so it is just series of evolutions. Like the concept of artificial intelligence came in the 1950s. Then in 1990 we saw the concept of machine learning. We talk about the machine learning algorithms. Then we saw the deep learnings. In 2010 we saw the deep learnings when we start getting the heavy hardwares, or the GPU. You can say that we saw a lot of improvement in the deep learning. And 2020 we saw after 2020 we have this era of generative AI and agentic AI. So if you talk about that, why we should learn this generative AI in 2026, or what are the area of improvement, what are the improvement we have in this generative AI. So first of all, if I compare the large language model capability that we have or we had in 2020, so almost 20 to 50 times or 100 times we have increased the context window. I'm not going the technicalities of these terminologies. So the context window is nothing but the input capability. And if we talk about nowadays, like I already mentioned, that we have the large language models available which can generate the 3-hour video content. I can remember that when I was playing with OpenAI Sora platform, which is a video generation platform. There we were able to generate only 10-second videos, 20-second videos. Then in 2022, we saw the content about 5 minutes, 6 minutes. And nowadays, this LLMs has evolved so much that they have the capability to create a 3-hour video content. Apart from that, nowadays it is only not limited to a single input. In the early days, we have a LLMs which can understand or which can take a specific type of inputs, either text data, either video data, audio data, or AI supported file format. But nowadays, we have the concept of the multimodals. And in this multimodal, what we have is these multimodals are not limited to only the one format. Multimodal means that we have the LLMs which can understand the multiple input. We have the LLMs which can take both text or text plus image as an input. We have the LLMs which can take text plus video as an input. Apart from this, nowadays, if we talk about the logical capability of the large language model, so nowadays we have the large language models which has crossed the human intelligence level in some of the tasks as well. Like if you talk about the task like translations, summarization, nowadays in this task, LLM is doing better than the human. We have many scenarios which is totally nowadays fully automated by the generative AI or the agentic AI. We have some use cases. We have some use cases where human is totally replaced by the AI agents. Why? Because we are using this advanced reasoning and the reflections pattern. We are using the different advanced prompt techniques to improve the LLM logical capabilities like COT, React, and also we are also working in this 2025, 2026. We are also working on very focused on the small language model SLM. We heard this terminology like 3 to 4 years before, but now in the last 1 or 2 years, we saw the huge improvement in the concept of SLM. And slowly, by the end of this year, you will see that your laptop or even your phone or the camera will have the basic large language model or the small language model, you can say that. So there is a chance where you can expect a SLM in your mobile phone, and I think Meta is also going the direction where they want to fit a small language model in the specs, basically in sunglasses they want to put some kind of a SLM. So these kind of evolutions that we have seen in the last year and up to this 2026, you have seen that last month Anthropic Claude is also launched its some plugins or some kind of a agents which can do a simple uh, automation things in the finance sector, in the HR domain, and also they have released some kind of a agent which can also help to find the bug or the security issues in the transactions. And this is the kind of a new improvement that we have in the field of agentic AI. So now to talk about the use case, you already have seen that almost every domain we have these AI agents, like we have the researcher agents, which ChatGPT, Claude, Perplexity, these all are using the research agent. We have the coding agent. If you see our GitHub Copilot, Cursor AI, we have Codium. These are the coding agents which help developers to improve their productivity. They help the developers to generate the code, to fix the bug, or perform the documentations. We have the QA agents which can automate our testing process. We have the agents which can totally replace by the HR to perform the interview, to onboard the candidates. So this kind of agents nowadays is very popular in the market, and few companies are already adopted this agent in their task. If we talk about recently, like I was interviewed for a company for the role of data scientist, and at that time when I got a call from the company side, so on the other side there was a HR AI agent. It was not a human person. So the call is coming from the AI agent, which is asking about my name, my experience, and my basic details. So all the conversation done by the AI agent. Later, AI agent used to create the summary and submit to the HR. So this kind of adoption is nowadays is very common in the IT sector. So now, for this today's session, like Gen AI is very vast. We have multiple topics in the Gen AI, and one of the topic that I picked for today is the fine tuning. We will discuss that what this concept of the fine tuning and why this concept is also very important, like other concept of the Gen AI. So if you talk about the simple Gen AI terminology, right, in this generative AI, what is happening? So in this Gen AI, what is happening? So basically, we have the concept of large language models. So we have seen this thing already, that we have the concept of large language model. We have these models from the different vendors, like OpenAI has own family of the models. Meta has own family of the model, Llama family. Then Anthropic has own family. We have Google Gemini has family. So all this, I have the different LLM providers. So we are picking up one of the LLM, and then we are writing our prompt. So what we used to write is we are writing our prompt. Prompt is nothing but we have some set of instructions that we are passing for the LLM. So we are passing these instructions for the LLM, and LLM is taking these instructions and generating the response. So this is the basic architecture that we have in the generative AI. We are passing our prompt, LLM understand my prompt and generate the response. But apart from that, we have many other concepts also in this generative AI. We have many other concepts, like maybe you also heard about the concept of prompt engineering. So, okay, Lisa has one doubt. Yeah, please, you can unmute yourself and you can ask your doubt also. Hello, someone has doubt. You can unmute yourself.
No, they won't be able to unmute themselves. We'll give the time at the end for questions Q&A. Okay. So, Abhijit has right. Okay. Sure. Abhijit, sorry, I think you've not. So we will once the session is done. At the end.
Yeah, let's keep the last 10 minutes only for the doubt session, guys, so that you can ask your doubts.
So Harish, if you could also walk us through what are the different elements involved. I guess right now we have come to fine tuning. There is something called RAG. There is something called multi-model.
This is what I'm going to show.
Thank you.
Yeah. So basically, if you talk about in this, this is what we are just covering now. So when we talk about the different components in the LLM, so we have seen that basic architecture in the Gen AI is that we have this LLM. As I mentioned, that we are passing the prompt and we are getting the response. Now, to improve the quality of the prompt, because you have seen that LLM is generating the response based on the quality of prompt that we are passing it, based on the instruction that we are passing it. If my instruction itself is ambiguous, or the confusion, so we can get a confused output from the LLM side. So to improve the prompt, we have a special branch, or you can say special type or element in the generative AI, and we are calling it as a prompt engineering. So one of the important concepts that we used to cover in the Gen AI is the prompt engineering, where our focus is to improve our input or the prompt so that we can get a expected output. Apart from that, we have another important concept that we have is RAG, R-A-G. Okay, so we are not covering this thing in the depth because this is just a master class and we're talking the fine tuning of the concept. So RAG is a concept where we are giving the LLM. So this is my LLM, and LLM is able to give the answer based on the knowledge on which LLM is trained. But if I want the LLM to give the answer of my question belong to my company or my personal documents, In that case, we have to provide a data source to the LLM, and this query will search the relevant document from my data source, and then the relevant information is passed to the LLM along with the user query and getting the response. I'm not covering the thing in the depth, guys, but we should be a little bit aware about the things. But this is the RAG, which improve your Gen AI architecture, which is mostly used. So RAG is the mostly commonly architecture that we use in the Gen AI almost in every company. Every company who is building solution in Gen AI, definitely 100%, these companies are directly or indirectly using the RAG architecture. Then after that, we have another very important concept. I'm not talking about only these three, guys. Apart from that, we have many other concepts also, but these are the more common important concept that we have. And the third thing is we have the fine tuning. Fine tuning is also, we will discuss about the deep. So fine tuning is also that element of the Gen AI where we are focused on to change the behavior of the LLM. Apart from that, we have the concept of SLM that we have already seen. That we have the concept of the quantization. So these kind of concepts that we have in the generative AI, and one of the concepts that we are planning to cover from this today's session is our So the concept that we're going to discuss in this today's session is our fine tuning. And in this fine tuning, first of all, we will understand that why we need this fine tuning, and then after that we will talk about that how we can do the fine tuning. Fine tuning itself is a very depth concept, so we will see that why we need the fine tuning and what is the process in the fine tuning that we have. Okay, so now let me check if you have. Okay. Yeah, there's no doubt, and let me start the quick discussions on the fine tuning. Yeah, let me just share my screen again. I have set up my code. So now we talk about the concept of the fine tuning. Let me just talk about a basic theory about the fine tuning. So what this fine tuning is, that fine tuning is, again, as I already mentioned, that it is a concept in Gen AI where the purpose is to improve the accuracy of the LLMs, because the main thing is that I want LLM to give the precise answer, but the problem is that LLMs has trained on the multiple domain, and they can give the answer of multi-domain questions, but the problem is that they are not expert in a single domain. But there might be requirement that I want a expert level answer from a specific domain. This is where the LLM are lacking. In this fine tuning, what we're doing is we try to train the model on my specific data set. We change some kind of a parameters of the large language model so that we can get a better alignment of the response for my user query. What we are doing in this fine tuning, what are the steps that we have in the fine tunings? So in the fine tunings, we are following the series of steps. The first steps is like we have to check that for which type of requirement we are doing the fine tuning. Requirements means that what is my problem statement, guys? My problem statement is kind of like summarization, that I want LLM to perform the summarization according to my requirement. Another can be a translation, that translation is not happening according to my expectation. It may be a code generation, that I want to generate the code according to my code practice that we are following it. So we have the multiple use cases. First of all, according to your company, according to your requirement, we have to select that what is your problem statement. Then after that, the second step that we have is prepare the data set. Prepare the data set means that You already have seen that LLM is not doing magic, guys. Okay, LLM is not doing magic by just, they don't have any magical powers to give the answer. They are basically trained on a huge amount of data, right? So how LLM is able to give the answer, because simply they are trained on this particular data. That's why they are able to give the answer. So if I provide my company data or my data on which I want LLM to give the answer, definitely I need to prepare the data. When I'm saying that prepare the data, means that we need some data and we need to clean the data according to my requirement. So the second step is that we are preparing the data set. The third step that we are following is that we are performing the tokenization and the formatting. So what this concept of tokenization is, I'm just giving a quick overview, not going in the depth. Tokenization means that till the step number 2, what we have is we have the text data, right? For example, we have the data like I am going to school. So for example, this kind of a data that we have, but my LLM only understands the numbers. My LLM or my machine only understand the numbers. They don't know about the English or any language. So in the concept of tokenization, we are breaking the sentence into small kind of words and then perform the vectorization. Okay. Then the step number 4 is very, very important. Step number 4 is we have to select the base model. What's the meaning of the base model is that the concept of the fine tuning is, please pay attention, this is important concept. The concept of the fine tuning is retrain a existing model. So the concept of fine tuning is to retrain a existing model. We are not building the model from the scratch, guys. Okay, this is very important concept that we should be aware of. So we are not building the model from the scratch. We have a existing model and we are just improving the efficiency of this existing model. So in the step number 4, we have to take a model. It can be a open source model like Llama family, you can take it. You can take the BERT, or you can take any LLM provider who provides the LLM for the fine tuning. Then after that, in the step number 5, we have to take some algorithms, like we have some techniques like LoRa, QLoRa that we have, and we are going to implement these algorithms on my base model with my data set. And the step number 6 is that after selecting the algorithm, or you can say that fine-tuning strategy is the right word here. So what we're doing is we are just setting up my fine-tuning strategy, and then after that, we're starting the training process. Once the training is complete, it's not like that we blindly deploy the model on the production. We have to check that whether there is an actual change in the accuracy or not, whether there's any improvement in the model or not. If the main objective of the fine-tuning is to improve the accuracy, improve the efficiency, but if the accuracy is not improving, there's no point of deploying the fine-tuned model. So we will evaluate the performance here, and once everything is good, then what we will do is we will go and deploy the model on the production, and my client will be ready to use my fine-tuned model. So this is a 8 step that we are following sequentially. So each step has own importance we have, and this follow a proper sequence. We start with the problem statement, prepare the data, perform the tokenization, selection the models, and configure the things, train the model, perform the evaluation and the deployment. So we have to go through these 8 steps. And now for this today demo, I'm going to implement all these 8 steps. Okay. So now what we can do is we can just go back to our coding part, and let me just open the code. Yeah, this is our code. I hope everyone can see the screen of coding file, guys. Can you please confirm if you can see my code file?
Yes, we can see that. Fine-tuning language model or domain-specific tasks, right?
Yeah, yes. So if you talk about the problem statement is, as I mentioned, that we are going to implement this 8 steps that we have seen in our fine-tuning life cycle. So what we are going to do is we are going to see the steps that we have seen. So the very first step that we're going to implement is that first of all we should be talk about our problem statement. So if you talk about the problem statement, the problem statement is a dialogue summarization. Okay. So if you talk about the problem statement, so what our problem statement is, that our problem statement is a dialogue summarization where I want to improve the efficiency of the existing model. I want to improve the existing model accuracy on the dialogue summarization. So if you talk about the data set, let me just share my screen and show you the dialogue summarization. Dialogue summarization Hugging Face. So this is my data set, or you can say that my problem statement is that I want to fine-tune the model to improve the efficiency of the model on this data set or dialogue summarization task. So we have the dialogue. Dialogue is nothing but the conversation between two or more person, and we have the summarized data. This is the human generated summary, and we want LLM to follow the same pattern that human generated summary is following. So this is our main requirement. Now the question comes that why we need the fine tuning. So I will also show you this thing, that why we need the fine tuning, and I will prove this thing that fine tuning definitely improve the efficiency of the LLM. So if you talk about the problem statement, step number 1 is the problem statement. The problem statement is that we want to improve the efficiency of the LLMs on the dialogue summarization. Then the second step was about my taking the data set. As I mentioned, that data set we already have seen that. I already mentioned that data set is from this Hugging Face dialogue summarization. This data set contain like thousands of lines. I'm not taking all the data set. I'm just taking the few hundred lines to perform the fine tuning. So step number 2 is also clear. In the step number 3, we are talking about the model's tokenization part. So tokenization part will be internally taken by the model. And the step number 4 is which model we are using. So if you talk about the model that I'm talking about, so this is my Queen 2.5 model, guys. So the model which I'm going to use is Queen 2.5 billion instruct model. This is a small model, and I'm going to run this thing on my local machine. So this is a small model, and I want to fine-tune this model on this data set. Then the step number 5 is that we have to choose the algorithm, right? So the algorithm which we are going to use is Qlora. I'm not going in the detail of this Qlora, but as we are just going to implement the steps which we already have seen here. So in the step number, if you see here in the step number 5, we are talking about the configuration. So the configuration here we are going to use is Qlora, and then after that we will train the model. We will run this code and check the performance. So before checking the fine-tuned model performance, we need to check the existing model performance. Okay. So what I'm going to do is I'm going to run this code, and pick some sample data to check that how good this Qwen 2.5 model is behaving on my data set. Okay, so basically we need to check that how good this model is existing behave, and how we can improve, or when we are doing the fine tuning, is there really change in the accuracy or not. So this is my requirement. So what I'm doing is I'm just importing this model. This model is on my local machine, and I'm importing this model in my from my local machine. And let me just run this code. Okay, so I call this model, and now what I'm going to do is, then I'm just taking this tokenizer, all the part that is already mentioned, the step number 3. So I'm just preparing this tokenizer, and then what I'm doing is I'm checking my evaluation data set. I'm just taking a data set around 10 lines. So what I'm going to do is I'm just going to check the existing accuracy of the model. How I can check these things? So what approach I'm doing is, let me just explain that. Please pay attention. So the what approach that we are following here, as I mentioned, that we are using the model which is Qwen 2.5 billion instruct model. So this model, basically I want to check the existing accuracy of this model on my data set. So what I'm doing is I'm passing the 10 samples. Basically I'm taking the 10 random samples and then ask this LLM to generate the summary. So what we're doing is we are asking this LLM to generate the summary, and corresponding to this LLM generated summary, we have the human generated summary also, which is we downloaded from the data set. So we have the human generated summary and we have the LLM generated summary. I will use this BERT score, which is an evaluation criteria, to check that how accurately LLM generated summary is aligned with the human generated summary. So this is what I'm going in my code. So let me just show you the things. So if you see here, I have taken the 10 samples from the data set, and now I'm using this model to generate the summary. So out of 10, 5 summary has been generated. And now what we are going to do is we are going to see that how accurate this LLM generated summary is aligned with the human generated summary. So this is our first phase. So generally we used to divide this fine tuning task in the 3 phases. So the phase number 1 is, which we are doing currently. The phase number 1 is check the need of fine tuning. Check the need of fine tuning. So we cannot blindly go with the fine tuning because fine tuning is a very expensive approach. So in this fine tuning, what we are doing is, in this fine tuning, we are checking the existing model accuracy, whether our model is good, and then we will check in the phase 1, we are checking the need of fine tuning. Phase 2, if we found that yes, my existing problem cannot be solved by the single LLM or the existing LLM, then we will go to the phase 2, where we will start the fine tuning. Then the phase 3 is evaluation of the fine tuned model. Evaluation of fine tuned model. Okay, so this is the 3-phase activity that we have. So what we have completed so far is that we are done with the first part, and now I'm going to evaluate this model. So if I'm running this code, which is going to perform the evaluation, and let me check the evaluation. So my model F1 score is 0.83, or you can say 83%. But my requirement is I want it make it around 95%, because in my critical task 83% is less, because I want to become more and more accurate. So now we are going to perform the fine tuning. In the fine tuning, I am not running it on my machine because it will take around half an hour or 1 hour to complete the fine tuning. So it's not possible in this session, but I can just show you the code that for the fine tuning, you can see that I'm setting up my LoRa configurations, as which is already we have seen that we need the LoRa configurations. So we are just using this algorithm, or you can say that we are using these fine tuning steps or the fine tuning algorithms to fine tune the model. And then after that, we are implementing this configuration on my same model and took this training data set which contained the 200 samples. Okay, so we are taking the 200 samples here, and then after that, from all these 200 samples, we start running our fine tuning. Just give me 1 minute. Okay, so now, as I mentioned, that we are just doing the fine tuning with our data set. And this is my trend data set, which contains the 200 examples. And then after that, we start implementing our fine tunings, guys. Okay, if I click these things, so my fine tuning will be started. But again, as I already mentioned, that it will take 30 minutes to 1 hour. So it's not possible to showcase this thing in this class. So we will start with the fine tuning. So what this fine tuning will give is, fine tuning will give me a adapters, or you can say that new weights or the new model which I'm going to save here. So on the left hand side, you can see this Queen to QLoRa adapters. So this is the outcome from the fine tuning, guys. So this QLoRa technique which I'm using it, this techniques is giving me the fine tuned model, and after this thing I'm going to implement the same things. Same thing means that now those 10 sample which I used earlier to evaluate the existing model without fine tuning, now after the fine tuning, I'm going to evaluate my fine tuned model on the same data set. So this code is doing the same thing. You can see that it is picking up the same 10 samples and start evaluating with the fine-tuned model. So this model is not the original one. This is the after doing the fine-tuning. So now our main purpose is that if we are spending this fine-tuning process, if we are spending our money on to improve the accuracy, is really happening or not? Is really improved or not? Right. So this is our main focus that we want to see, and it is just testing with the fine-tuned model in the real time. So I already have done this fine-tuning before the class, so that I can just show you the things and I can show you the comparison. So now fine-tuning model which we have, so I'm using that model to perform the summarization on the same data set which I used without fine tuning. So now it's about to complete, and then we will see then we will see the same evaluation on the same data set and see that it's really improved or not. So when I was running this code, I was running this for 1 or 2 epochs, not for the large time, but definitely if I run this code for the 1 hour or 2 hours, so definitely we can expect the more accuracy. So now my samples is completed. So 9 out of 10 is complete. 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 Yeah, now 10 is complete, and now I will just perform the evaluation, and this is taken the same 10 sample, and now my accuracy is 88%. If I just compare the things what we had earlier, so this is now my conversation, and preferences is my original one, and this is my prediction, which is quite aligned with the preferences one. Now, if I just check the accuracy, or you can say my average before the fine tuning and after the fine tuning, you can see that on the original model, we have the accuracy of 83%. And in a small fine tuning, I'm not taking a big data, I'm not taking I'm not doing this fine tuning for like a couple of hours. I did this fine tuning only for the 5 minutes or the 10 minutes, guys. And within these things, you can see that we can see a 5% increment of in the accuracy. Definitely, if I do the same process for the longer duration with a large data set, definitely we can see a significant improvement in the accuracy. If I'm running the code uh, and I'm running this fine-tuning task only for the 15 minutes, and within the 15 minutes, if I can say the 5 minutes accuracy, if I run this code for 1 hour or 2 hours, so definitely my accuracy definitely may reach to 95+%. So this is the benefit of the fine-tuning. And in the company level, yes, we used to do this activity. This is a very common activity that we used to do it, where we take our base model and fine tune the base model for a client specific task to improve the efficiency. So yeah, so now I can take your doubts. So maybe you can unmute yourself and ask your doubts.
You guys can raise your hands if you have any questions, and then we can unmute you for the same.
So I'm not able to see anything in the chat, so I request the participants to maybe unmute yourself.
No, Harish, yeah. So they won't be able to unmute. They will be able to raise their hands. Once they raise their hands, Subha has a question. I'm going to unmute and allow to talk. So please go ahead. Subha, I have requested on. Yes, you can ask your question.
Harish, for that presentation. It was very informative. And the question I do have is, can you please go show me exactly what are the parameters that you passed to the fine-tuning model? That is one question I do have. And second question I have regarding the small language models, right? If small language models are the future, then how these LLMs is going to help us, or what will be the future of LLMs?
Okay, so let me take the second question first. So the future of LLM is, see, we need the LLM
Question,
not only.
can you hear
You
me?
can hear me, right? Yeah, I can hear you, right?
Hello?
You can hear me, guys? Hello?
Yes. Subha, can you hear us? We can hear you, Subha.
Yeah, Subha, can you hear me? Subha, can you hear us? Okay, let me just give the answer of this question. So I'm giving the second question answer first. So the thing is, like, participant question is like, Harish, what will be the future of LLM? Like, you have seen the SLM is also taking the pace. So basically, what happened so far is LLM is only using to build software-based applications. We are not putting them in the hardwares. As of now, whenever we are calling a LLM which is installed in your laptop, anything we need either a big heavy hardware, like we need the GPUs, we need a heavy machines. But so far, we are not able to embed the large language model in the cameras or in our mobile phone because of the size, because this embedding model size, this LLM model size is like in GBs, like 5 GB to 500 GB. So we are also doing the R&D in this SLM area as well, so that we can significantly reduce the size of the large language model that can be fit in my mobile phone, in my cameras, so that we don't need to call any APIs to call this model on the cloud. This is the first thing. The second thing is, like, you want to see the code. Sorry. So let me share my screen. So if we are, sorry guys. So let me just share my screen. Wait a minute. Yeah. So you want to see the code. So I can just explain the code, what actually the fine tuning is doing. So basically, this is the main part of the code. Yeah, this is the main part. So first of all, what I'm doing is I'm setting up my LoRa configuration. So this is my main parameter. As I mentioned that I'm going to use the LoRa configuration. So R stands for the rank. I'm using 8. LoRa alpha is the scaling factor. What are the layers which I'm going to implement the LoRa? So Q and V layer, I'm using it to implement or to change during this fine tuning. LoRa dropout is something to the dropout that we have in the deep learning. What type of task I have? So these are my LoRa configurations. And then I'm setting up the another parameters about my hardware, that per device, what will be the bed size, gradient size, steps, learning rate. So these kind of things which I'm putting in my training parameter. And after these things, I'm creating this SFT trainer object and pass my training data, pass my evaluation data, and start applying these things on my data and start implement this training process, and it will start reducing the loss, the traditional way of doing the training process. So we are just implementing that steps with the LoRa things, and they keep learning the things from the data from the loss functions we are implementing it. And over the period of times, as the number of epochs is increasing, over the period of time, my model will also keep increasing and improve the accuracy. I hope it's clear now.
Subha, you're allowed to talk. If you have a follow-up question, you can ask. Chandana, you can launch the poll if you want. Subha, if you have a follow-up question, you're unmuted.
I'm good. No, I think. Thank you.
Okay.
And also, I do have a separate question, if I can ask you.
Yeah, please, Shubha.
Yeah, we did this for summarization, right? How it will impact the other areas of, for example, the translation or maybe other, areas of scores.
Are you talking about the same model or the different model?
Yeah, the same model you fine tune for the summarization, for example. Maybe if we are using the same model for some different purpose, right? For like a kind of
Its
a
accuracy will be
translation.
affected. Yes, its accuracy will be affected because we are changing the behavior of the LLM for a particular task. Correct.
Yeah.
So, or because your requirement is that I want to make my LLM perfect for my one activity, and definitely if you want to change or if you want to use this fine-tuned model for the other activity, I'm not saying that it will be zero, but yes, accuracy will be affected.
Okay. Thank you.
Okay, thank you all. Then have a great rest of your day. Happy weekend, folks. Thank you, Harish.
Thanks, Steve. Thanks, everyone.